Hello, good morning to this demo and presentation, small presentation given by Yannick Struijf. Yannick Struijf is senior SE in Belgium and Luxembourg. He joined actually a couple of months ago, but he's a DevOps specialist. He talks and walks DevOps, so we are very fortunate to have him in our team in Belgium and Luxembourg. So he has put together for our team a demo of Karbon and Ansible and objects, all in a DevOps CI/CD pipeline. So he did it already for our team, but I thought it was a good idea to share this with the world and with all the EMEA SEs or everybody who is interested in how our technology, our different functionalities in this broader umbrella of the DevOps world and the automation and orchestration. So I'm gonna shut down and I give the hand to our specialist, Yannick Struijf. The stage is yours.
Thank you for the introduction. So let's keep it a bit interactive if possible. If there are any questions, just unmute yourself, ask the question, or ask it via chat, and then I will come back to the question. Now, the demo that I will show today is indeed about we did this demo is because a customer of us requested a demo and they wanted to see what was possible with Karbon and Ansible. So let me go to the next slide. So what are the goals of the demo? It was to automate a Kubernetes cluster deployment. As Nutanix, we have a product for that called Nutanix Karbon, so we chose to use that, of course. The customer also wanted to create buckets, so Nutanix objects buckets on demand, so with an automation tool. And the end goal was to allow developers to easily provision Kubernetes clusters. So the idea was that they would have one large production Kubernetes cluster, and that each developer could easily request their own Kubernetes cluster. This is, of course, a perfect use case for Nutanix Karbon. And additionally, they also wanted to use more of the Nutanix objects. So they also want the developers to provision buckets on demand. Everything needs to be integrated in a pipeline. Our customer already used a lot of pipelines and a lot of CI/CD integrations. So this should also fit in the integration of the customer. And they also wanted to see how objects, so Nutanix objects, can be used in an application. So it was a pretty large scope, but the scope was not the only problem. We also had a few tooling requirements. So the customer was already using Bitbucket, so it's actually a version control system, a Git type of product. They are also standardized on Ansible. So if anything would be automated, it had to be via Ansible. For pipelining, they were already using Jenkins, so it also had to integrate with Jenkins. And last but not least, they already used Nexus for their Docker images and general artifact storage. Maybe a bit of additional information about Nexus. The reason why the customer chose Nexus is because they have image scanning. So if you create a new Docker image, you upload it to Nexus, you can see the vulnerabilities in the image by the image scanning of Nexus. So these are the technologies that we are using, and of course also the Nutanix technologies. I will now go a bit deeper to give a bit more explanation about, in this case now, Ansible. So for those of you that know or do not know Ansible, Ansible is a configuration management tool. It has a very large open source community. And if we look at the Benelux region, it's a tool that we see coming up more and more, and that has a lot more traction these days. It's Python based, so if you are a bit of a Python programmer, it's easy to create your own images, your own modules, and to create your own playbooks. And actually, what makes Ansible different compared to regular scripting or bash scripting is that you do not really write your scripts, but you just define the desired state. And additionally, Ansible has a concept of idempotency. Now, what is idempotency? The most easy example that I can give is folder creation. So on the left on the slide, on the left bottom on the slide, you see mkdir my folder. So if you, for example, create a bash script where you need to create a folder in the simplest case, you run the script once and it will create a folder. You run the script twice and you will get an error because the folder already exists. Now, if you go the route with Ansible, and that's on the right upper corner, you just define that you want to have a file or a directory with the name my folder. And below that, you see your first run. So you will check, is the file or the directory already there? If it's not there, it will create it. If it's already there on the second run, it won't do anything. It will just say the state is okay. So this gives a huge advantage, not only for initial provisioning, but also for compliance checking. A few of our customers also use Ansible for their Nutanix cluster configuration. So they set up the cluster and configure the cluster with Ansible. And then periodically, they run Ansible again and to check which configuration values need to change or have changed during the period of time. So next up is Karbon. So what is Karbon? It's actually a product of Nutanix that is used to deploy Kubernetes clusters on demand. It's starting from Karbon 2.0 integrated directly into Prism Central. And the benefit is that you can have Kubernetes lifecycle management. So deploying a Kubernetes cluster initially is fairly easy with a bit of Linux background, but keeping it up to date and make sure that it can be upgraded and that the security patches are applied is a bit more tricky. So that's why Nutanix Karbon helps the customers a lot, because you upgrade your OS images and you can also upgrade your Kubernetes version itself. On top of that, if you use the Nutanix Karbon, it automatically installs the Nutanix CSI driver, which basically means that you can use a Nutanix storage for persistent volumes. So if you have a database or something in your container environment, the persistent storage can directly be stored on Nutanix storage. Next up is Nutanix Objects. Okay, Nutanix Objects. So it's a simple and secure object-based storage. It can store all of your unstructured data. It is completely S3 compatible, which will also be clear in the demo. It can be used for massive scale. It's easy to deploy, and it's also integrated in Prism Central. So this is a bit of context about the products that we will use. Now, what does the demo environment look like? So like I mentioned before, we are using Bitbucket, or we need to use Bitbucket. So what we are using is Bitbucket in the cloud, so the cloud version of Bitbucket. Then we have a demo environment consisting of a Nutanix cluster with multiple nodes. And on top of that, we already have our object storage deployed, and we have one production Kubernetes cluster deployed. The Jenkins that will be used to run the pipeline and the Nexus are also running in containers on top of the production Kubernetes Karbon cluster. So this is the first initial phase of the demo environment. Now, what is the first step is that we need to create a Karbon cluster. Of course, the Karbon cluster needs to be deployed via Ansible. So the first step from a developer point of view is that he would pull the Ansible code from the Bitbucket, and that he can give his configuration, for example, on which Nutanix cluster it needs to be provisioned, how many worker nodes you want, etc. If the configuration has been created, the cluster can be created by talking or via the Ansible module and the Ansible module will talk to Prism Central, and he will create for you the Karbon cluster. Now, it's not only deploying the plain Kubernetes cluster that we will do, we will make sure that the Kubernetes cluster is fully configured and can be used or consumed by the developer instantly. So that means that we don't only deploy the Kubernetes cluster, but we also deploy Metal LB on top of that. It's actually, you can use it for having a load balancer within your Kubernetes cluster. So it's a software load balancer that also runs in containers. And for ingress routing, we use Nginx. Now, what is ingress? Ingress basically means that if you have FQDN, for example, myapp.nutanix.local, and you have another application, myapp2.nutanix.local, using an ingress, Kubernetes knows which pods are linked to which FQDN. But more on that later. So the first step is creating the cluster. Now, because it can take a fairly bit of time to create a cluster, I already provisioned it. So before the presentation started, I ran the Ansible playbook. So I just run the playbook. I give my inventory file. The inventory file dictates which host and which variables will be used for my playbook. And I have my own playbook here that deploys the Karbon cluster for me. Now, what will he do? If you look at the different steps, so first he will check if there's already a Karbon cluster with my requirements available. And if it's not available, it will create it for me. So this has happened. So let me show it in Prism. So if you have your dashboard, your Prism Central dashboard, and you want to see your Karbon clusters, you just go to Karbon, and it will load your clusters. So this is a cluster that was provisioned a few minutes ago. So it's a cluster using one of the latest OS images, and it contains 2 worker nodes. Now, what does it look like from a playbook point of view? So the first step is to create the cluster, of course, and this is an Ansible module that I've written custom for the demo. So this is a module that is exactly like default Ansible modules, but it's purely using the Nutanix Karbon APIs. So you just need to enter your Prism Central credentials, so like you normally do with a manual deploy. You give the credentials of the underlying Nutanix cluster on which you want to deploy your Karbon cluster. You give your network settings, you give your Karbon image, and you dictate how many workers you want to modify. So for the demo, I now deployed 2 workers, but the module has been written in such a way that if you put 3 workers, for example, and you rerun the Ansible playbook, that the Ansible will invoke a scale up on the Kubernetes cluster via Karbon. So I can show that later. So the next steps are then make sure that all of the workers can access my registry. So that's my Nexus. And what we then will do is install all of the Kubernetes prerequisites. We will install the UI, we will install the Metal LB, we will install the ingress, and last but not least, we will deploy a test up to check if the cluster is available. So here we have a URL, so http apache.karbon.yst.nginx.local. So this is an example of the ingress. So I created an ingress route for apache.karbon.yst.nginx.local. And this in the backend points to pods, and it works. So this is just a basic test to show that the Kubernetes is working, that the ingress is working, and that the Metal LB is working. So if you want to consume the cluster, you need to have, of course, if you're a bit familiar with how Kubernetes works, is you need to have a kubectl file. So it's this file that you require. My Ansible module also fetches the kubeconfig file directly from Karbon, so it can be used directly by the developer. So if I export my kubeconfig file, oh, sorry, kubeconfig, okay. So this is directly on my Kubernetes environment. So now I see the different namespaces that were created. So a few were created by default. I have my ingress, I have my metal LB, I have my Nutanix system, which is also created by default, and I have my test application. Small note, if I press K, it's an alias for kubectl. Time is money, right? So if I want to show you the UI, I can use the proxy, and now I can run the UI. Okay, kubeconfig file. Now I need to go to the correct path. Well, and we have our Nutanix web UI. So basically, with one simple Ansible command, you can create a Nutanix Karbon cluster that is directly available for your developers after a few minutes. Now, having a Kubernetes cluster is one thing. Make it consumable and make it usable in a pipeline, that's another question. Now, before we continue with the Kubernetes part, we will now show you the objects part. So the next idea is that we want to create a bucket. So the same idea is that a developer pulls or defines the bucket in code. So it's actually a bit like an infrastructure as code concept. He modifies one of the configurations for the bucket, or he creates an initial bucket. He pushes the code to Bitbucket. Bitbucket will then have a change on the repo, so the Git configuration or the Git contents have been changed. This change will be picked up by Jenkins, so in a CI/CD and pipeline fashion. And what Jenkins then will do is it will use Ansible. Again, it will use Ansible to create the bucket, and not only create the bucket, but it will also upload the content that was defined in the infrastructure as code kind of methodology. So that's the next scenario. So also for this, I created a custom Ansible module that can create buckets for you. So it's called Nutanix Bucket. You give your bucket a name, you pass it an object store, which in this case already exists. You give your credentials to your Prism Central, and you define your bucket permissions. Now, from a developer point of view, he only needs to define which files he wants to add to the object or to the bucket, and it will be uploaded automatically for him. So I will now go to my Git repo. So I have a different Git repo where we store our files. So you see different files or folders here with files in it. So now as a developer, I create a change in my Git repo. Change status. So I've written some code, or I modified the contents of the Git repo. So now I push. So now my content is pushed to Bitbucket. And in the meanwhile, I have my Jenkins. So this is Jenkins for the people that have not seen Jenkins before, or that are not aware what Jenkins does. So let me log in for a second. So this is Jenkins, and the two lines you see over here, these are my individual pipelines. So now I have a pipeline for my objects, and what he does is he periodically checks Bitbucket for changes in the repo. So I push now to Bitbucket, but it can take a while before Jenkins picks up the change. So now you saw that there is a change on the Git repo, and now he will execute my pipeline. And the pipeline, like I said before, is checking the contents of the files that were in the Git repo. So in my case, it's the files that are in files 2019 or files that are in 2020 configuration file. He will run Ansible, and he will instruct Ansible to create the bucket for me and to upload the files to the bucket. Now, what is a great advantage of using Nutanix objects, also from an automation perspective, is that if you look at the playbook itself, I first have written my own module because we as Nutanix do not yet have the Ansible modules out of the box. So I've written it myself. And after the bucket has been created, I can use the default AWS Ansible modules to upload the files to the bucket. So what I just did is I went to the Ansible website, I looked up the default AWS S3 module, and I took one of the examples and I implemented it. So it's very easy for customers that are already using Amazon S3 or have already based themselves on Amazon S3 to also use the same kind of automation on the Nutanix Objects cluster on-prem. Okay, so now he's in progress. So what do we see? He's executing the pipeline, he's looking at the files, and he's running Ansible. Now, a cool thing to note maybe is that in my current setup, Jenkins will spin up a pod, so a container, with Ansible in it, and with Ansible, he will then create the buckets. So that means that after this run is completed, so it's completed now, the pod is destroyed and there are no traces of the pod or of the run itself, besides, of course, what we see here in Jenkins. So if I now check my objects, so I used this object store called bucket. It now created this bucket with 4 files in it, which also corresponds with the different files that we see here. Okay, so now what we already have done is we have created a cluster, a Karbon cluster on demand. We've created a bucket on demand purely via infrastructure as code. The next step is, of course, to deploy an application. As same methodology, a developer writes an application on his laptop. He pushes the code to Bitbucket, which is in my case in the cloud. Jenkins will poll for changes in the repo. Then Jenkins will start the pipeline, and the pipeline actually exists of 2 steps. The first step is to build the image and to push the image to the image registry. The next step is to instruct Ansible to deploy an application on the newly provisioned Karbon cluster based on the image in Nexus. The application that the developer has written is an application that uses the objects in the bucket that we have created earlier. Okay, this may seem a bit abstract, but I will run it like we did before. So again, we go to a different repo. So it's carved as demo app. It's actually, so we have a Docker file that just is based on the Flask container image, where we just add our application in it and we install additional requirements for the application to run. We have our Jenkins file, and then we have some Python code that defines the application. Now, I am not a web developer, so it's really a very simple application, but nonetheless, it works. Okay, so again, as a developer, I code some stuff. I have a change in my Git repo, git commits modified readme git push. So again, Bitbucket now has a new commit. This will be then picked up by Jenkins. So it's the other pipeline, it's the Devops pipeline. So again, it's periodically checking the changes on the Git repo. And after, I think, 1 or 2 minutes, we will see the new change incoming, and he will build a container and he will push the container to Nexus. He will then instruct Ansible to deploy the application on the newly provisioned Kubernetes cluster, and everything should be up and running. Now, how do I provision the application itself on the Kubernetes cluster? Let me show you. So to deploy the application, it's actually very easy because we, as Nutanix, we just deploy a plain Kubernetes. So that means that all of the Kubernetes playbooks or Kubernetes scripts or YAML files that the customer is already using, they can just reuse it for our Nutanix Karbon deployments. So again, what I did is I went to the Ansible website. I looked up how you can create Kubernetes pods and ingress routes. I just added them to my playbook, and it can be used without any issue. So let me see if my Ansible is already in progress. Yes. So now he is performing the changes. So the first step is creating the Docker image. So that's what he is now doing, as you see here, unpacking and running pip install the requirements. So this can take a while. Are there any questions in the meantime, or is it all clear? Maybe via chat if you have any questions. I don't see any questions in chat. Okay. So let's wait a bit for it to complete. Is the Ansible module official? Well, not yet. There are 2 reasons for that. The first reason is that the Karbon APIs are not officially yet available. So actually it's a bit of, I would not say unsupported, but it's not yet recommended to use the Karbon APIs. Now I've started before version 2 of Karbon with the module. Now I've upgraded to Karbon 2.0, and actually the API changes were very minimal, so the risk is pretty low in my opinion. The second reason is that if this module would be publicly available, then we would have to give support on that, or I personally would have to give support on that. So what we are looking at Nutanix as a whole is to see how we can allow customers to use our own Ansible modules from Nutanix, and not only for Karbon. But that's something that I want to do in the near future, to offer Ansible modules for different use cases. Okay, so now the image has been uploaded, or yeah, I believe it's being uploaded. So this is Nexus. So it's just an artifact store. It's from Sonatype. It has image scanning included. So it now created the K8s demo app with the tag latest. So this can now be used in all of the Kubernetes clusters that we have provisioned. So now he already did all of the steps required to provision the application. So let me see. So now he created a new namespace called demo. KNS demo. If you are interested in KNS, so there's a plugin called kubectl namespaces, and this can easily allow you to switch between namespaces. Okay, so the pod is online. Get services. The service is also online. So if I now press the URL, we have our Nutanix demo web app. Now, as you can see, I'm not a very good UI designer. I'm also very bad in choosing background, graphics, and logos. Now, the main question you may ask is, why are you using Nutanix objects? Well, the images are pulled from objects dynamically. So within the application, he pulls the images from the object store itself. And also the different slogans are also coming from the object store. Now, the advantages of using a Nutanix object store or a bucket is that you actually decouple some of the data from your application. And because we are now using infrastructure as code also for our objects, it's very easy to change the data. So if you go to your objects demo, let me show you. So in my inventory file, over here, I defined which folder I need to push to my bucket. Now, the great thing is, and also this holds the idempotency concept of Ansible, is that if I change something in my configuration file, modified to new logo, push. So I modified the configuration file. So basically, instead of using files 2019, I will now use files 2020. And what Ansible will do is, again, so Jenkins will see that there is a change in the Git repo, the pipeline will run. But Ansible will now see that the object, so the Nutanix bucket, is already existing. So he will not fail or he will not recreate it again. And the thing is that he will then upload the objects directly to, he will upload the new objects to the object store. So this is now in progress. So let me see if he is busy. So it's still waiting for the change to occur. Now we have a question to deploy an application. I think only one command kubectl should be enough. Why Ansible is being used? Well, the thing is, the customer is is taking baby steps with regards to containers, but the customer already knows Ansible. So it was easier for them to show you that you can create individual objects using Ansible. And indeed, the next cases would then be using Helm, for example, or plain YAML files to invoke it. Because also a lot of the pipelines that they are using are based upon Ansible, it was easier for the customer to grasp the idea of how it can be used in a pipeline. But I agree, if you are more familiar with Kubernetes, with kubectl, etc., it's more logic to not use Ansible in this case, because Kubernetes already does a lot of the idempotency concepts for you. So I agree. Of course, I need to check the correct pipeline. So it's built in on master. Okay, console output. Okay, so he updated the, voila. So with a simple new git push, I changed the layout of my website purely by changing the contents in the Nutanix bucket itself. So this was actually a demo to show the customer what is possible with Ansible, with APIs, with Nutanix and with Karbon. And the customer is now looking into purchasing additional clusters, Nutanix clusters, purely dedicated for running Karbon and also objects. So this was actually the demo that I wanted to show you. We have seen, I think, a lot of use cases. We've seen a lot of technologies that are now being integrated together. Are there any additional questions besides the one in chat? No, not really. Maybe one additional thing, because you to show you the idempotency of. So what I said is the worker count is also something that has been coded in the module. So if I now specify that I want 3 worker nodes, so by modifying the config file here, Karbon status, so it's modified, deploy. Okay, so now my Ansible module sees that he needs to create a scale up or perform a scale up on the Kubernetes cluster itself. And if I now go to my Kubernetes cluster hub, Karbon. See, now he's adding the worker node. And after he has added the worker node, he will check also the rest of the services if they are still running and still compliant according to the configuration of the Ansible playbook. Okay, this was the demo. I hope you guys enjoyed it a bit. I hope it was clear. If there are any additional questions or you want to see a bit more, you can always ping me on Slack. And yeah, I wish you a very pleasant day.
Okay, thank you, Yannick, for this use case where we could see all the technologies working together. And this was really a nice showcase of a full pipeline and how all things fit together and where our technologies fit in the broader solution. So thanks a lot for everybody who was on the call. We will do this type of demos and presentations more. Next week we will have one on files by Wim van den Broek, but the week after we will promote and publish some more demos and presentations from out of the Belux SET. Okay, guys, stay safe. See you. Bye.